Have you ever looked at a math problem and just felt stuck? Like you're staring in a locked door? Well, today, we're going to hand you the key. We are breaking down a really clever strategy for solving systems of equations that turns a super confusing problem into a clear path forward. So, here's our roadmap for today. We're going to start with what makes these problems a level 2 challenge. Then, we'll introduce our master strategy for solving it, walk through an example step by step, point out some common traps to avoid, and finally, see how this stuff actually applies in the real world.
All right, let's dive right in. We're leveling up from the basics here. See, sometimes the equations you get aren't perfectly set up and ready to go. They need a little prep work before you can really solve them. You can think of it like doing a little warm-up before the main workout.
So, what happens when you see an equation that looks like this? X plus y equals 5. You know, in simpler problems, you might get an equation that's already solved for a variable, like y equals something. But here, you can't just substitute right away. We've got to do a little bit of work first.
And that work is our first key move. The whole goal is to isolate one of the variables, to get it all by itself on one side of the equals sign. When we do that, we create what we're going to call our blob, basically a chunk of the equation that we can then plug into the other one.
And that brings us to the core idea for today. Honestly, it's more than just a rule. It's a whole strategy for making algebra way easier. It's all about looking at the problem and choosing the smartest, most efficient path to get to the solution. It's about working smarter, not harder.
And here it is, the lonely variable strategy. When you're deciding which variable to get by itself, you always look for one that has a coefficient of 1 or -1. That just means a variable with no number in front of it, or maybe just a negative sign. This right here is your easy path. And trust me, its main purpose is to help you avoid dealing with messy fractions.
Okay, this slide shows exactly what I'm talking about. On the left, in our good choice, notice that x is lonely. To get it by itself, you just add 3y to both sides. No fractions, nice and clean. But look at the right. If you try to isolate y in that equation, you have to divide everything by 5. And that creates fractions, which is exactly the headache we're trying to avoid.
All right, enough with the theory. The best way to really get this is to see it in action. So let's grab a sample problem and walk through it together, using our new strategy step by step.
We're going to follow a super simple 4-step process. Number 1, isolate that lonely variable to create your blob. Number 2, substitute that blob into the other equation. 3, solve the new equation you just made. And 4, my favorite part, the boomerang step. You use that answer to swing back and find the final variable.
Okay, here's our system. We have x plus 2y equals 6 and 3x minus 4y equals 28. Just take a second and look at it. Can you spot the lonely variable? Yep, you got it. It's the x in that first equation. It has a coefficient of 1, which makes it our perfect target.
All right, step 1, isolate. We take that first equation, we subtract 2y from both sides, and bam, we get the x all by itself. We now have x equals -2y plus 6. And that expression on the right, the -2y plus 6, that is our blob. Now for step 2, substitute. We take our blob and we plug it in for x in the second equation. This part is so important, you have to use the equation you haven't touched yet. So 3x becomes 3 times our entire blob, -2y plus 6. And those parentheses are key. They make sure we multiply the whole blob by 3.
And now, step 3, solve. Here's the magic. We now have an equation with only one variable, just y. So we distribute the 3 into the parentheses, we combine our y terms, and we just solve for y. And when the dust settles, we find that y equals -1. We are halfway there.
And for the grand finale, step 4, the boomerang. We take the answer we just found, y equals -1, and we throw it right back into that easy-peasy equation we made back in step 1. So we plug -1 in for y, that gives us x equals -2 times -1 plus 6, which simplifies right down to x equals 8.
And there you have it. The solution to the whole system is the point 8, -1. That is the single coordinate pair that makes both of our original equations true. If you were to graph these two lines, that's the one point where they would cross.
Now, the process is pretty clear, but there are a few common mistakes that can still trip you up. So let's go over them right now so you can make sure to avoid these little traps.
So be really careful with these 3 common traps. First, plugging the blob into the wrong equation. Remember, you have to substitute it into the other equation, not the one you just used.
Second, forgetting to flip the sign. It's a classic mistake, so just double-check your work when you move a term across that equal sign. And third, be precise. If you create a blob for x, make sure it actually replaces the x, not the y, in the other equation.
So at this point, you might be wondering, okay, that's a neat trick for my algebra class, but why does this actually matter? Well, believe it or not, this exact type of thinking powers huge decisions in the real world every single day.
Take something like resource allocation. Imagine a factory manager. They have limits, right? A limited number of machine hours, a limited number of employee hours. By setting up a system of equations for those limits, they can use this exact substitution method to find the perfect balance, the schedule that gets them the most output without going over budget. It's the same logic we just used.
And really, that's the big takeaway here. The lonely variable strategy is more than just a math technique. It's a problem-solving mindset. It's about looking at a complex situation, finding the simplest way in, and using that to unravel the whole thing. So, I'll leave you with this question. Now that you know how to find the easy path in an equation, where else can this strategy help you solve problems?